everybody who is watching this video. My name is Olenjolai TAYAI single from beautiful country called Tanzania, eastern of the African continent. I would like to take this moment to welcome you onto our online programs that's called the Online Diploma Polytechnic Institute of Tanzania. And also let's take this moment to welcome you onto one of our platform where we deliver fantastic material for the students. It's called our YouTube channel. That's called the Online Diploma Polyinstitute of Tanzania, in square bracket Olenjolai. Well, I would like just to spend a few minutes to remind you the vision that we have in this platform, so that you may go through and even you may understand that where are we heading to. What visions in my mind as a founder of these programs? This is the vision that God has revealed in my mind at the picture, that I would like to be a part of them, of the trainers or of the teachers or of the engineers, whatever that just you can call of the tutorial assistants, who will prepare best technicians who will be ready to take the classroom instructions in engineering and scientific mathematics, classroom instructions of science, classroom instructions of engineering, combined together with the spiritual knowledge of Word of God, and then going back to our community to solve real life problems. So our main objective in this platform is to solve real life problems. It's not even just to pass for the exams. However, that one of our specific objective, we help students to pass the exam. So once you are connected with this platform, you should not worry about passing for your continuous assessment or for your final exams. Really believe me that I'll be trying my level best to pour out to prepare at the best technicians. And the best technicians is the one who is competent in the classroom instructions and also competent in the outside instructions, mean that in solving real life problems. So that will be our main focus. So it's not something which is easy to achieve it. It's a process, but I'm ready to be a part of that process. I'll be building up your mindset step to step. So in order for you to get connected, that we like to remind you, if this is your first sessions, okay, don't worry about that. We have session 00. You have to make sure that you watch session 00 of conics and differential questions to session 03, which already in our official YouTube channels, and you have to make sure that you subscribe so you get notification, because we are going to add a video every day into this our YouTube channels, and we're gonna put more than 100 videos continuously. So you have to make sure that you subscribe and you share these contents with your classmates, with your friends, with your young brothers, with some other students. So in this platform we are teaching, currently we are in departments of engineering and scientific mathematics, where that we are training ordinary diploma students to think differently from the concept, to grasp all the concepts of engineering, basic engineering and scientific mathematics, so that they will apply in the year course. So today I would like to be a part of, I would like to teach the third year students. However, that these contents are equivalent to the contents that the advanced students or advanced secondary students are covering also during the year educations of the Form 6 of the college geometry ones, which is the first topic in the Form 5. So today I will be mentoring, I will be teaching, I will be training you step to step about the scientific and engineering, basically scientific and engineering mathematics in the modules or in the course that we call the conics and the differential question. Conics is nothing, it's just the coordinate geometry, so don't worry about the vocabularies of conics. So we have already covered the 4 lectures, but including lecture 0 or session 00, which is called the general introductions of basic scientific and engineering mathematics for ordinary diploma first year to the 3rd year. It means NTA levels 4 to NTA level 6. So today we are in session 4 or in lecture 4. The main topic that we have is called the cycle for NTA level 6, and this is the 3rd year. Our main objective in these NTA levels, or to prepare the best technicians, we want to prepare them to be with the mindset of the competence based. So even in mathematics, we'll be trying our level best that you become competent. So today we are in session 4, and session 4 is titled as equation of the tangent line to the cycle. So I will be teaching you how you can find the equation of the tangent line. And I will give you a bonus. I will give you a bonus that I can even introduce to you, and even I can introduce to you about the equations of the common chords, or the equation of the second line, and kind of just I will show you just the second line. I will be reminding you also about I will introduce to you about the equations of the normal. Okay, because in other conic sections, parabola, ellipse, and even hyperbola, we also touch the concepts of the equations of the normal. So I will show you, because always these two concepts they go in parallel. It means tangent and the common tangent and normal line. So let us go to the business right now. Let me do the quick review. Okay, the quick review of session 3. It has been titled as problem solving regarding equation of the cycle passing through 3 points. So the general equation, just to remind you, means that I taught you how you can use these general equations on solving the equations, on the solving problems. And the general equation is x squared plus y squared plus 2gx plus 2fx, and then plus 2gx gy, and then plus c, this is equal to 0. But also, if you do remember that we say that the radius as radius, or we say that radius minus a square minus b square, this is equal to c. If you do remember c, what is c square? So it means that c is equal to the square root of what? Square of the radius minus a square minus b square. So that's what we have been discussing, that will be given to find the equation of the line. Maybe you'll be given this 3 points, 3,4, and another point it is -1,2, and another point is 0, let's say, comma 2. So find the equations of the line that passing. But also we have been trying our level best to also to deal with equations of find the equations or find the center and radius of the cycle. So we did a lot of stuff. So for you to get too much details, just make sure that you watch session 03 in the same YouTube channels before you continue with session 4. So in session 4 I have to teach about the equation of the tangent line. Firstly, I know your history or your backgrounds of 14, your backgrounds as the sake, okay? I know your backgrounds of the concepts of the equations of the tangent line. That is something new in your mind. But possibly when you be learning about the differentiation, you learned about the tangent line. But let me just remind you. So the first vocabulary that we have to cover is what the meanings of tangent line, right? Tangent line. So that is the fundamental question. What is tangent line? Okay, in mathematics, what is tangent line, right? So what is tangent line? That's the fundamental question. So tangent line, we say that is a straight line. Is a straight line, okay, that touches any curve, okay, touches any curve, okay, any curve. So when you say that any curve, such as a cycle, or a parabola, or hyperbola, or any other shape or ellipse, etc., okay, touches at only one point. So it's perspective of coordinate geometry. We say that the tangent lines touches only a cycle at only one point. So in the straight line that touches, so this is touches, okay? So this is T, right? So let me write it clearly. This is T and this is U. Touches any curve, okay, at only one point. So for the tangent lines to the cycle, it means that it's a straight line that touches a cycle at only one point, not more than one point. So that is one of the vocabulary. The second vocabulary that we want to understand in advance is the vocabularies that we call the tangent point. Okay, tangent point. Say tangent point. What is tangent points? That is the second question. What is tangent point? What is tangent point? What is tangent point? Okay, tangent point simply say that is a point whereby the straight line, whereby the tangent line, right? The tangent line, normal line, and the cycle or curve, such as cycle, right? Such as cycle, okay? Intersect or meet, in other words. So the point of tangent, so tangent point is the point whereby the tangent line, normal line, and curve, such as a cycle, intersect. Okay, intersect or meet. That's the meaning of the tangent point. So, so let us go to our geometrical. You said that the geometrical representation. Geometrical representation. That's called the geometrical representation. Geometrical representations of what? Of tangent line. Okay, of the tangent line, tangent and normal line. Okay, normal line is a cycle. Okay, so we say that consider figure below. So this, let's say figure 4, okay, A below. So we can have the geometrical representation. Suppose that this is the XY, this is the Y axis, so it's XY plane, okay, XY plane. This is just like a geometrical representation, so you can see in terms of geometry. So this is Y axis, and this point it's X axis. So this is original point. Suppose that you have a cycle, might not maybe accurate in drawing the cycle, but don't worry, you have to focus. So what the tangent line? So for instance, this is the tangent line, right? So you have a certain straight line, okay? You have a certain straight line which touches at only one point, not more than one point. So this is straight line for the, if you remember, they call the geometry of the form 4, you say the general equations of the straight line is mx plus c, okay? So m stands for the slope, x stands for x coordinates, and c stands for the y-intercept. But again, we have a perpendicular line here, okay? We have a perpendicular line which is perpendicular, okay? Means that straight is 90 degrees with this straight line, okay? So then this is the normal line. So this one, we call it tangent line, okay? And here we have variety M, or 90 degree. And this one, we call it normal line. So we have tangent line and normal line. At this point P, and this point P, which we are, for this case, we call it x comma y. So this in mathematics, we say that point P is called is tangent point. So this is tangent point. And this is figure 4a. So this is the cycle. So remember the equation of the cycle. It is x squared plus y squared. This is equal to what? This is equal to r squared. So r means that radius. So that's the equations of the cycle. So from this equation of the cycle, you see that we have one tangent line. The tangent lines, it should not be maybe only at this point. It can be tangents at any point along the curve, along the circumference of this cycle. This is the cycle. Remember that this is the cycle. This is the cycle. This is x-axis. This is y-axis. So that is the numerical representation of 40 of of tangent and normal lines. Tangent and normal lines. Well, so we have noticed that equation of the tangent line has a special characteristics, and the characteristics that it only touches the circle at only one point. So because it only touches the circle at only one point, so there are the conditions, which we have to condition the y-intercept, right? The y-intercept should be conditioned. So we should have a conditions from these general equations, y is equal to mx plus c. We have to condition the y-intercept in order for the tangent line to be a tangent, or in order for a straight line to be a tangent to the circle. So there are the conditions for a straight line to be what? A tangent to the circle. Also there are the conditions just to give you a bonus, or to give you some material that you need in future. There's the condition for the straight line to be a tangent to the parabola. There's the condition for the straight line to be a tangent to the ellipse. And there's the condition for the straight line to be tangent to the hyperbola. So let us start with the next concept. Okay, so he said that condition for a straight line. For a straight line, condition for a straight line, y is equal to mx plus c to be tangent, okay? To be tangent to the circle. So simply, let me begin with there is the condition. There is the condition necessary. The condition necessary for the straight line. For the straight line to be tangent. The straight line to be tangent to the circle. So now we have to derive, okay? So what is that? So we said that derivation of the condition for a straight line, y is equal to mx. Remember that this program is for the serious students. Okay, so you have to make sure that you have a pen beside you. You have reference books, as I have mentioned in general lecture, or in session 00. Okay, to be a tangent. Okay, to the circle. So to demonstrate this condition, we say that to show this, to find or to determine or to derive this condition necessary for the tangent, for the straight line to be a tangent to the circle, which also will be what? So you say that these conditions is very important because the fundamental idea for even for the next lectures or next sessions, when we'll be learning about the second conic section, which is parabola, the third which is ellipse, and the fourth which is hyperbola. And I would like to tell you, make sure to preserve this information because you need them when you'll be pursuing your undergraduate studies. For instance, for example, you'll be learning these concepts of ellipse, parabola, and hyperbola in the concepts of differential equations when it will be the second year in the modules that called the advanced calculus. So in advanced calculus, there's a topic called the partial differential equation. So when we learn some partial differential equations, these three conic sections, parabola, ellipse, and the hyperbola, are used to classify ordinary differential equations of the second order. So we'll be following several steps. The first step, for this case, you said that consider the figure 4, okay? Consider the figure 4. So this is called the, consider figure 4a. Consider the figure 4a. Okay? So when you consider this figure 4a, we say that we have a tangent line. So we say that the equation of the tangent line is y is equal to mx plus c. And also equation of the cycle centered at origin, this is x squared plus y squared is equal to r squared, means radius squared. So if that's the case, we say that the second step, we say that find, okay, so how it means that at this point P, at 20P, both the straight lines, the tangent line and curve meet. So because they meet, it means that we say solve simultaneous equations, okay? Or it means that solve simultaneous equations, okay? Let us solve simultaneous equation of what? Of cycle. So simultaneous equation of cycle and the tangent line. How do we solve? We say that tangent line y mx plus c, while the cycle it is x squared plus y squared is equal to radius squared. So suppose that this is equation 1 and this is equation 2. So in order to solve, we say that substitute. So this will be the third step. Third step, we say that substitute equation 1 into equation 2. Okay? Substitute equation 1 into equation 2, we have x squared, and then y it is what? Y it is mx plus c squared, and this is equal to the square of the radius. Right? So then we say that x squared plus, so this one, if we define it, plus c according to the laws of algebra or laws of expansions of algebraic expressions, this is what we will get. So again, if we do further expansions, mx times mx, we get m squared and then x squared plus mx times c and then plus mx. Okay, so let me just go slowly. So we get that this will be mxc plus c times mx is equal to mxc, and then c plus c, this is equal to c squared, right? C times c squared. Okay? And then minus what? Minus radius squared is equal to 0. Right? So these are the like terms. These are the like terms, so we can add them. So we have to add according to the laws of algebra. Also here x squared is common, so I can take x squared out of the bracket. Here remains 1 plus m squared plus what? Mathematics is beautiful and you have to start enjoying from today. So twice mcx plus what? The y in the, okay, c squared minus r squared is equal to 0. Okay? So then if you check this equation, it is a quadratic equation. Okay? So suppose that this is equation 3. So we go for the first step. The first step is this. Equation 3 is the so we say that equation 3 is the quadratic equation. Okay, it's the quadratic equation equivalent to ax squared plus bx plus c. Okay? So equivalent to that one. So how do we compare these two equations before even record the general formula? It's equal to c, it's equal to 0. So if you write this one in the same format, we have 1 plus m squared x squared plus twice mc x plus c squared, then minus what? radius square of the cycle is equal to 0. So suppose that this is equation 4. Okay, equation 4. So we go for the fifth step. The fifth step, we say that we can compare. We can compare what? We can compare equation 3 and what? And the equation 4. How? So you find that A, coefficient of the general quadratic equation, is 1 plus m squared. And then B, coefficient of the general quadratic equation, this is equal to 2mc. And then you find C, coefficients of quadratic is equal to c squared minus r squared. Right? So those are the coefficients of the general quadratic equation. So you go for the sixth, so after having them, you go for the sixth step. So you say that you have to recall the general formula. Have to recall the general formula for quadratic equation. So general formula for quadratic equation. So the general formula for quadratic equations is stated that if you are solving for x, this is equal to negative b, okay, plus or minus square root of what? Square root of b squared minus 4ac, then divided by 2a, twice a. So that's the general formula of solving any quadratic equation. Okay? Any quadratic equation. So because that is quadratic equation, now we can substitute the coefficient of the equation 3 into the general formula, right? Mathematics, engineering, basic engineering and scientific mathematics is very beautiful. You have to start enjoying it because it's beautiful, and you have to enjoy it for the rest of your life, right? So then we say that we are looking for we are solving for x, right? So we say b is equal to negative 2mc plus or minus square root. Then since square root, we have b squared. So what is b squared? It is 2mc, so we have to square, minus 4. What is a? A is 1 plus m squared. And then what is c? C squared. C is c squared minus r squared, right? So then this one over twice a. What is a? So a is 1 plus m squared. So we have just replaced the value of a, b, c in these general equations with these values. Right? Good. So then we go for the seventh step. The seventh step, we say that at the point of tangents, we say that this equation, right, or this formula, will give us 2 points. 1 point will be negative 2mc plus this square root of this term over 2 open bracket 1 plus m squared. And the second value is negative 2mc minus square root of this expression over this expression. So you have 2 points. So you have 2 conditions. So the 7 steps that you say that the condition for a straight line, condition for a straight line to be tangent to the cycle, is intersecting with cycle at only 1 point. So if this is the case, we say that at that only 1 point, we have only 2 coordinates x, y, right? Only 1 point. So for that case, we'll be just to consider. So consider only 1 point. So it means that we say that in order to have 1 point, this part should be 0, right? So if it will be 0, it means negative 2mc plus or minus 0 over this one, which means it will conditions that the result of this formula to have only 1 point and not more than 1 point, right? So for this condition, we say that it means that for this condition to be, means for the tangents to intersect with the cycle at only 1 point, then we say that the square root of 2mc square, right, minus 4 times 1 plus m square, and then here we have c square minus r square, right, even divided by what? Because this is common, right, common denominator, okay, this one. So this should be equal to 0 for the straight line to be tangent to the cycle, and even for the straight line to be tangent for any conic section. So if this is the case, we say that we can multiply, so you can say that we can multiply by this item, means that by 2, so you can multiply by 2 to both sides. So you can have 2 plus 2m square on this left side, then we multiply with the square root of what? Of 2mc square minus 4, 1 plus m square, and then so c square minus r square, and this one should be equal to 0 times 2 plus 2m square. So we multiply by this denominator to both sides of the equal sign. So when we multiply it, we find that because here we still have on this side, we still have 2 plus 2m square, so this one and this one will cancel. Alright? If you understand what am I teaching you, please let me know and get a feedback so we can thank God together in the comment section of this video. Okay? So if that's the case now, we say that here it remains with the square root. It remains with the square root, which is 2mc square minus 4. Then we have 1 plus m square, and then you have c square minus r square. This is equal to 0. So you have to square to both sides to make the radical side, right? So afterward we have 2mc, and this one is square, minus 4. So 1 times c is c square, 1 times negative r square, it is negative r square, and m square times c square, this is m square c square, m square times this r, so it is m square r square. And then this one is equal to what? Is equal to 0, right? So if you expand these expressions, this will be 4 m square c square minus 4 c square, then plus 4 r square, then minus or plus 4 m square c square, then plus, if you expand, 4 times 4 m square r square, this is equal to 0, right? So that's our new equation. So if you join me right now, you're warmly welcome onto this session 4 or lecture 4 of derivations of the conditions. What am I teaching right now? I'm deriving the conditions necessary for a straight line to be tangent to the cycle. So you're welcome. So then if we examine and if we examine these expressions, we find that 1 times c square, it is c square, 1 times negative r square, it is negative r square, m square times c square, this is positive m square c square. So m square times r square is equal to negative m square r square. So if that's the case, we say that this is negative 4c square, this will be positive 4r square, this is negative 4m square times c square plus 4m square times r square is equal to 0. So this term is like with this term, but they differ in sign. So it means 4m square c square minus 4m square c square give us 0. So finally we remain with negative 4c square plus what? Plus 4r square, and then plus what? Plus 4m square then r square is equal to 0. Right? Good. So if that's the case, we say that, okay, 4 is common. So you can divide by 4, okay, to the left-hand side and even right-hand side of the equation. So finally, remains is negative c square after dividing with r square plus m square r square is equal to 0. So then bring this negative c square on right-hand side. So this is r square, m square, r square is equal to c square. Then make c the subject. So if you make c the subject, or just to continue, we say that r square is common. So it remains is 1 plus m square. This is equal to c square. So make c the subject. So to make c the subject, it will be the under root of what? Of r square 1 plus m square. So if we find these expressions, the square root of r it is r. Okay, the square root of r it is r. And then we have square root of what? 1 plus m square. Finally, this is the good news. The condition for the straight line to be a tangent, it means that c, the y-intercept of the straight line, should be equal to the products of radius of the cycle times square root of 1 plus the square of the gradient of the straight line. Right? So we say that the condition, the necessary condition for the straight line, okay, for the straight line, so the straight line y is equal to mx, y is equal to mx plus what? Plus c, to be what? To be tangent to the cycle. Be tangent to the cycle x square plus r square. X square plus y square is equal to r square. It is that c should be equal to the radius, products of the radius of the cycle, then square root of 1 plus square of the gradient. So this is necessary condition, and you have to remember it for the rest of your life. You see how mathematics is beautiful? How many procedures did we follow? Just 7 steps. But this is the queen of engineering, right? It's very beautiful. I like it. And I would like also to convince you to love for the rest of your life. Okay, so now we have the condition necessary for the straight line y and x to be tangent to the cycle x square plus y square. So then the next step now, which I have to teach you, how we can use these conditions now to get the equation or the equation of the tangent line to the cycle, right? So we say that I would like just to give it the subtitle as equation of the tangent to a cycle, right? So then now I want to teach you now the general or the equation of the equation. So now let me teach you equation of the tangent. So I want to teach you how you can deduce the equation of the tangent line. The equation of the tangent line to the cycle. Equation of the tangent line to the cycle. So simply say that y is equal to mx plus c. Also, remember that the condition for the straight line to be tangent to the cycle is given as c squared is equal to the products of radius of the cycle times square root of 1 plus m squared. So if that's the case, we say that now the equation of the cycle is equal to mx, and this is plus r or radius, then square root of what? 1 plus m squared. So simply say that the general equation of the tangent line to the circle. The circle is given as this. Y is equal to gradient of the straight line, x plus radius of the circle, square root of what? Of 1 plus square of the gradient. So this is the general equation of the circle. Okay? I want to give you a bonus point. Okay? Bonus concept. And this is the bonus concept that I want to give now. I gave you a bonus when I sketched figure 4, but we say that this is not before. Refer figure 4. Figure 4a. Okay? So you say that the tangent line is perpendicular. Say perpendicular. So the tangent line is perpendicular to the normal line. So if these are perpendicular lines, so you say that for perpendicular lines, you have to remember also what we taught you in coordinate geometry. For perpendicular lines of the form 4, we told you that for perpendicular lines, the slope of the first perpendicular line times slope of the second perpendicular line, the product should be equal to -1, right? So for instance, if we say that let MT to be slope of 40 of tangent line, right? We are going to use this concept often, okay? The perpendicular lines, means the gradients of perpendicular lines. And then suppose that MN, this is the slope of the normal line. Slope of the normal line. So if that the case that we say that the products, slope of the tangent line and slope of the normal line, these should be equal to -1. Even if that the question will ask you to find the equation of the tangent line, but you can use this formula to determine the slope of the tangent line. How? It means that the slope of the tangent line, if we know the slope of the normal lines, this will be equal to the reciprocal -1 or negative reciprocal of the slope of the tangent line. And I will remind you this concept as we continue learning the concepts of conics. So in every conic sections, we are going to use that concept. Okay, so you know the geometrical representation, you know the conditions necessary for the tangent line to be, for the straight line to be a tangent to the circle. Now, I would like just to take you into a very interesting point, and where that I have to teach you about the equation of the tangent line, right? With the angle between the tangent and the x-axis. Equation of the tangent line. Okay, so let us go to the next example, and this will be example, and maybe how many examples there, so let me check. Hopefully we ended the 5 examples. Yes, 5 examples. And the left one are the 5 examples according to this sequence. We had example 1, 2, example 3, example 4, example 5, and that one is what we call the example, find the equation of the circle passing through that one's example 6. Example 6, and this one. Okay, well, so this is, you write the number, forgot the number of example, so you have to cross-check the previous lecture. But I want now to solve a problem with you. Find the equation. Find the equation of the tangent line. Find the equation of the tangent line. The tangent line at point A, and these coordinates are 3, 4 on the cycle. Okay? On the cycle x squared plus y squared minus twice x minus 6y. And 6y plus 5 is equal to 0. That's the question. Find the equation of the tangent line at point 3, 4 on the cycle x squared plus y squared minus 2x minus 6y plus 5 is equal to 0. So that's the question. Find the equation of the tangent line at the point A, 3, 4, on the cycle x squared plus y squared minus twice x minus 6y plus 5 is equal to 0. Very simple questions. But let us do it. It seems like a difficult question for you, but don't worry. Solution. Find the equation of the tangent line at that point, okay? On the cycle that one, fine. So we'll be following steps on solving this problem. In order to find the equation of the tangent line, you have to remember that you can, the first step, we say that sketch. In coordinate geometry, sketch the problem. We simplify problems by sketching them, right? So you can sketch it roughly, right? So this is your x, y axis. So to get the picture of what you have to deal with. So then possibly that there is a certain point, 3, 4. So suppose that you have a cycle. You have a certain cycle, right? And then there's a certain point here, which equal to 3, 4, okay? 3, 4, somewhere here, okay? 3, 4, we can say that somewhere here. So suppose that this is point P, this is 3, 4. So there's a tangent line passing at that point, right? So passing at that point, touching at only one point. So maybe in my sketching you find that this tangent line, it has touched the several points. But that is just a sketch. And this cycle, so the equation of this cycle, it's a one that will be given there, x squared plus y squared minus twice x minus twice y plus 5 is equal to 0. And this is the center of the cycle, let's say 0, 0. Maybe like a center of the cycle like that one. So let us find the second step. First of all, this is not the center of the cycle. Excuse me. It's not the center of the cycle. So you just sketch the problem, but it's not the center of the cycle. A good sketch, you'll get it when you see the challenge there, when you have the center. When you have the center of the cycle, then you can have a very well exactly sketch, but that is roughly. So sketch the problem roughly. So this is the rough, it's not a full sketch. Second step. So the second step, what we have been asked the questions of this question, the question of this straight line. Like this straight line is passed to one point at 3, 4. So again, if you examine, we have a normal line, right? And also, if you have a normal line, suppose that this normal line is just crossing the center, right? Or crossing the center. So suppose that this is the center, T3 may be the center. So, okay. So, in simple presentation, suppose this is the normal line which is perpendicular to this straight line. So it means that if we know the equation or the slope of the normal line, we can find the slope of the tangent line. So if we know the slope and we know one point that the line has passed, we can determine this equation. The second step. So second step, it means that in order for us to know the equations of the normal, which will be, because the equation of the normal will be passing through the center of the cycle, we have first of all to determine what? Radius and what? Radius and center. So let us determine radius and center of the cycle. Radius and center of the cycle. So what the cycle will be given? X squared. So collect the like terms. So we have x squared minus twice x plus y squared minus what? Minus 61 plus 5. This is equal to 0. So we have to use what? So remember that we have to use the concept of difference of 2 square. So this, it means we take x, open bracket, we take x instead of x square, then we find the half of this middle term. The coefficient here it is 2. 2 over 2 is 1. And then we square plus what? Y. So we take only single y here because we have y square. Minus or refer lecture 3, we dealt with I solved the main examples when I explained this concept. The half of the middle term, which is the middle terms of 60, is 3. So this one is square plus what? Plus 5, or we can even bring this 5 on this side. So it means that, or we can have even this one. We can have even post plus 5. So how we can, so you have to think the way around that to make sure that this equation, if you expand these expressions, we get the previous expression. So in order to achieve it, it means that we have to think that we have to subtract it with this middle term square, which is 1, and then we have to subtract it this middle term square, which is 9. So it's equal to 0, right? So what does it mean? If you expand this expression, you get x squared minus twice x squared minus twice x plus 1. So 1 minus 1, you get 0. If you expand these expressions, you get y squared minus 6y, like in these expressions. 0 plus 9, but 9 minus 9, you get it 0. So if that's the case, you say that x minus 1 square plus y minus 3 square plus, this is minus 10, 5 minus 10 is equal to negative 5 is equal to 0. So then we say that x minus 1 square plus y minus 3 square, this is equal to 5, right? So if that's the case, we go for the third step of solving this problem. We say that we have to compare, suppose that this is equation 1, we have to compare equation 1 with what is the standard equation of the cycle. What the standard equation of the cycle? Okay? Standard equation of the cycle is x squared plus y squared is equal to r squared. So if we compare, but we have to think about that. But this is a standard one, but it's not including what? The centers. So to include the centers, if a is the center, x minus a squared plus what? So this is translated a cycle, y minus b squared is equal to r squared. So if you compare, the comparison, you get that negative a is equal to negative 1. So negative over negative, you get positive. Therefore, x-axis for the center is equal to 1. And y-axis for the center, which is equivalent to b, is equal to 3. And then radius is equal to the square root of 5. Right? So it means that for that case, we find that center is not 0, 0, it's 1, 3. While radius of the circle is equal to the square root of 5 units. Right? So because you know the center and you know the radius, now you can sketch. So you go now, the first step. The first step, you say that sketch what? Sketch the cycle. Okay, so to sketch the cycle, suppose that this is figure 4b. So here we want to sketch figure 4b, figure 4c. Okay. Okay, so this is the x-axis and this is the y-axis. Okay, so you have 1, 3 and you have another point which is x equal 3. So suppose that this is 0, 1, 2, 3, 4. Then suppose that this is 1, -1, -2, -3, etc. Suppose that this is 1, 2, 3, 4. Suppose that this is -1, -2, -3. So the center is equal to 1, 3. So 1, 3. So this is the center. So this is the center of the circle. And then the point is 3, 4. So 3, 4. 3, 4. Okay. This is the one of the coordinate. Okay, one of the coordinate. So then we say that the radius from this point to this point, this is equal to the square root of 5, means the distance. And the center here is 1, 3. This point is 3, 4. Right? So then we can sketch now circle. So I can roughly sketch. For you, you can use a coin of 200 to draw it with the same, with a circle, with a constant radius. Okay? So then the question of the cycle that we are looking for is the one that touches only this point. Touches only this point. Y is equal to mx plus c. Okay. So this is the equation. This is the straight line for the tangent line. Well, so if that's the case, we say that here you have perpendicular line. Okay? So remember that this is the tangent line, and this is the normal line. And these are perpendicular lines, right? So you have several tangent lines. Okay? Good. So if that's the case, we say that Okay, so he said that, so that the first step, so you go for the fifth step. The fifth step, what the simplest way that to find the equation of this tangent line? The simplest way is first of all to find the gradient of the normal lines, because I have two coordinates, I have 2 points. So we say that let us find, okay, the slope of 40 of normal line. So this slope of normal line, we call it L. So the slope of the normal line is equal to change in y over change in x, as we told you from since we are in Form 1 until we have been in Form 4. Okay? So change in y for this case, we decide. Just the y is 4 minus change in minus 3. And here we have x2 minus x1, which is 1. And hence the answer in numerator is 1. And here in denominator it is a half. So slope of the gradient, slope of the normal line is a half. So then we go for the sixth step. We say that, remember that I told you that the slope of the normal line is perpendicular, or normal line. So we say that the normal line, yes, the normal line, normal line is perpendicular to the tangent line. So if that's the case, you say that products, if you want to find the products of the tangent line, this is equal to -1 over products of the normal line. Okay? Products of the normal line. So if this is the case, you say that this is -1, and hence the slope of the normal line is equal to a half. So simply, the slope of the tangent line is equal to -2. Right? So now we know the gradients of this tangent line and 1 point. So just to go for the seventh step. The seventh step now, we say that let us find the equation. Questions of 40, question of the tangent line. Question of the tangent line. So to find the question of the tangent line, we say that we have this gradient. So tangent line, so we have to say let P x comma y to be what? To be any point or not, or any point lies on the tangent line, right? Tangent line. So we say that slope is equal to change in y over change in x. Okay? Slope is equal to change in y over change in x. I'm about to finish this session, so just be patient. Okay? So we say that the slope of the normal line now, slope of the normal line, this will be equal to the y minus the point of tangents, y coordinates of point of tangents, and x minus x coordinates of the point of tangent. The slope of the normal line is -2. So we have y minus 4 over x minus 3. This is equal to -2 over 1 with cross multiplication, right? So y minus 4, this is equal to what? -2x plus 6, right? So this is equal to y negative twice x plus 6 plus 4, right? So this is y is equal to negative twice x plus 10. So this is the equation of the straight of the tangent. So therefore, we say that the equation of tangent line to the given circle is what? Y is equal to negative twice x plus 10. You enjoy the beauty of engineering and scientific mathematics. So now it's the time for the homework 4. Time for the homework 4. It's a time for the homework 4. It's a time for the homework 4. It's a time for the homework 4. Okay, so this is again homework 4. Make sure to do and submit in the comment section. Homework 4. But for us also this will be example. So previous, just example A, substitute the value of A, let's say example B. Then we substitute what does B, I will cross check. Then the question is asking like this one, find the equation of the tangent line passing through point Q, and this point Q, it is 4,5, okay, to the cycle x squared plus y squared minus 4x minus 10y plus 9. Okay, plus 9, no, plus 16. This is equal to 0. So make sure that you do this homework and then you submit your homework in the comment section of this video. In the comment section. Very simple question. You just use the materials and the details, explanations that I've given you in this lecture. So this is the end of lecture 4 or session 4 of a question of the tangent line. So if you do this example, I'll be sure that, and even I'll be happy that every student who have taken this material from the beginning to the end, now you can solve problems, or you can solve problems that ask you to ask the question, find the question of the tangent line, and even if it will be a kind of a trick of the trick questions, maybe to find the question of the normal, you can also solve. And even sometimes that maybe can be given the tangents point. So the style of the questions might be different, but you have also to use your own mind that God has given you. So I'd like to thank God who have been with me in this, during the preparation of this session. And I'd like to thank you also for taking your time and joining me in this fantastic program. And I'd like to invite you in lecture 5. In lecture 5, I'm going to teach you another concept which is very interesting very interesting in the coordinating or in the conics concept. But I will be continuing with the topic of the cycle. So make sure that you do many questions as well as you can, and make sure that you get times to pray for me in order to achieve the vision for this program, and also I will be praying for you. Again, I would like just to remind you, if you go on the descriptions of this video, you will see even links of our other 5 official YouTube channels, because we have 3, we have 2 institutions, we have 2 secondary schools, we have 2 spiritual schools. So make sure that you read the descriptions of this video to get links of other schools and institutions for the rest of your life. So in case also you feel from your heart that you want to offer God the Thanksgiving offering, you are warmly welcome, and God really waiting people like you to do it, and the Thanksgiving will be received, and in order it will be used effectively to pay the running cost for the more contents and more lectures or videos of conics and differential questions to be in air. There are the high running cost. God didn't give me permission to share with you, but in case you feel the free willing Thanksgiving offering that you want to offer God, not the just you want to support this program, no, just you want to offer God the Thanksgiving offering for what He has brought in your house, for what He has brought in your car, for what He has brought in your mind, because this material, believe me, at the times that will be going on with this course or this module, you'll find that these informations will be shifting from the exercise book that you have written into your mind, and they'll be there for the rest of your life. And the good thing that of conic sections, for instance, that is very important, and you will see its applications when you'll be learning about satellites, when you'll be learning about satellite dishes, antennas designs, and different structures. So geometry is very important in engineering. So may God bless you and see you in the next session, which is session or lecture 5 of cycle. So may God bless you. See you there.